As populations surge and cities sprawl, available land is swallowed up by asphalt and concrete. We've built incredibly dense, industrial environments where open ground space is virtually non-existent. This extreme density brings severe consequences. Vehicle exhaust and industrial runoff create a heavy blanket of air pollution, while the sheer monotony of endless gray walls generates chronic mental fatigue for the people living inside them. To counter this, city dwellers are looking upward. By converting a balcony or a rooftop into a terrace garden, you secure a private outdoor retreat. Plants naturally filter the surrounding air, and the simple act of tending to them provides a psychological release from city life. But putting a forest in the sky means accounting for thousands of pounds of wet dirt and living roots, and managing that downward force hundreds of feet above the street. You are forcing an artificial ecosystem to thrive in a location where the building structure was never naturally intended to support it. You cannot simply scatter seeds on a flat roof and hope for the best. Building an urban oasis requires a strict understanding of structural load limits and botanical chemistry to prevent water damage to the building right below your feet. Before a single speck of dirt comes upstairs, we have to look at the foundation. The existing concrete roof has to be completely structurally sound and heavily waterproofed. This diagram illustrates the physical limits we are working with. According to civil engineers, a standard cement roof can safely bear exactly 48 kilograms per square foot. Every brick, plant, and drop of water you add eats into that strictly capped capacity. Stagnant water is the primary structural threat. Because water is heavy, we have to add a layer of lime terracing to create a distinct slope. This ensures excess rainwater drains off rather than pooling and eventually seeping through the ceiling. As a final barrier, builders lay down an 800-gauge polyethylene sheet. This thick plastic acts as a continuous waterproof envelope across the entire sloping roof before the soil ever touches it. With the base secured, the human elements go in. Low retaining walls hold the soil back, and paved walking areas using local stones, wood planks, or mosaic tiles give you a dry surface to actually stand on. Through deliberate engineering, what was once a fragile cap on top of a building becomes a reinforced, waterproof platform, fully prepared to sustain life. Now we bring in the greenery. You have two options: arranging movable pots for flexibility, or building permanent raised brick beds directly into the architecture. Those permanent beds and lawns have to be elevated and sealed with tightly cemented edges. This keeps the soil locked in place during a rainstorm, preventing erosion and keeping the plant roots from drowning in standing water. Look at this chart breaking down soil chemistry. Without natural ground earth, you must mix 2 parts standard garden soil with 1 part leaf mold, 1 part compost, and 1 part sand. It provides the drainage and nutrition these plants need. Once you treat that mixture with a 1% formalin solution to kill off diseases, you can plant. For a rooftop lawn, Japanese grass, or Zoysia japonica, is ideal, planted by hand on a strict 10 to 15 centimeter grid. Moving upward, account for the canopy. High altitudes mean high solar radiation, and that extreme, unfiltered sunlight dictates exactly what you can grow. Hardy, sun-loving plants like roses and chrysanthemums thrive in the open glare. But delicate shade-loving species like Boston ferns and begonias scorch without protection. To protect them, you install a horticultural roof. You stretch 70 to 80% agro shade netting over the ferns, while using 200-micron UV-stabilized polythene to shield fragile flowers from heavy rain. By actively managing the precise chemical makeup of the earth below and the specific intensity of the light above, a gardener essentially builds an entirely customized microclimate from scratch. A finished terrace garden looks idyllic, but the reality demands an intense amount of labor. The initial construction is expensive, and keeping the space alive requires constant daily upkeep. Pest control is especially difficult. Because you are working in a confined, elevated space closely attached to a living area, using traditional, harsh chemical pesticides is often avoided for safety. The plants are entirely dependent on you for life support. That means maintaining targeted drip irrigation systems, regular weeding, precise pruning, and constant repotting as root systems expand in a constrained space. This graphic shows the dietary requirements for artificial soil. Because rain washes nutrients out quickly, You have to frequently replenish the beds with dried cow dung and a strict ratio of 15-15-15 nitrogen, phosphorus, and potassium fertilizer applied at 5 to 10 grams per pot. Yet the logistics are often outweighed by the specific benefits of an elevated sanctuary. These gardens offer immediate privacy from neighbors and a dedicated space for rest that can improve mental health and add long-term value to the property. Bringing soil to the sky is a serious commitment. It is an intentional, calculated pushback against the sprawl of the concrete environment. By respecting the rules of structural physics and understanding botanical science, you can carve out a piece of the natural world, engineering a thriving, living canopy in the middle of the densest cities on Earth.